Hi class, this is Professor Smith. I'll be doing question number 7 from the final exam review part 2 on finding the partial fraction decomposition. It turns out I've done this problem once and recorded it, but it had no video, just audio, so you couldn't see what I was talking about. Now what I'll do is I'll open up math type so that you can see what I would be writing if I were using paper and pencil or if I were writing on the whiteboard. So the first step that we want to do when we're solving this problem is to factor the denominator. And once we factor the denominator, then that'll tell us how we should decompose the fraction. So we notice that the denominator has an x and an x squared. So I'm going to factor out an x, and that'll leave me with the x times x minus 1 in the denominator. Whenever you have linear factors, then it's going to decompose a over the first linear factor and then b over the second linear factor. So that's how you decompose it if you have distinct linear factors. The next thing that we're going to do is we're going to multiply both sides by the LCD, which is x times x minus 1. So I've color-coded it so that the x times x minus 1 is multiplied on the left, and to each term on the right, I've used the distributive property. The next thing we're going to do is cancel the common factors, and that's the purpose of multiplying by the LCD, to change the rational equation to an equation that no longer has denominators. Canceling the common factors, x and x minus 1 on the left. On the right, we're going to cancel the x, leaving us with x minus 1 times a. For the second term on the right, we're going to cancel the x minus 1, leaving us with x times b. Now we need to solve for the coefficients, and we do that by letting x equal the zeros of the two common factors, of the two distinct factors. So one distinct factor was x, so we're going to let it equal 0, and then x minus 1 was the other factor, so we're going to let x equal 1. So we're going to take the expression 3x minus 2 equal to a times x minus 1 plus bx and let x equal 0. Substituting in x equal to 0, we have negative 3 times 0 minus 2 equal to a times 0 minus 1 plus b times 0. Notice that this distinct linear factor where x was multiplied is going to vanish, so we have the b times 0, which was 0. A times negative 1 will leave us with the opposite of a. And then, of course, on the left, negative 3 times 0 is 0 minus 2 is negative 2. So we'll have the equation that negative 2 equals minus a. Multiplying both sides by negative 1, we'll get 2 equals a. Now we're going to let x equal the other distinct linear factor, equal the 0 of the other linear factor. So x equal to 1. And we have negative 3 times 1 minus 2 equal to a times 1 minus 1 plus b times 1. Simplifying, we have negative 3 minus 2 on the left, and then we have a times 0 plus b. And again, the other distinct factor had the x minus 1. That term is going to cancel, leaving us with negative 5 equals b. Now that we've solved for those two variables, we can rewrite the rational expression with those values, a equal to 2 and b equal to negative 5. So the rational expression 3x minus 2 over x times x minus 1 is equal to a over x, which is 2 over x, plus b, which is negative 5 over x minus 1. We can simplify the 2 over x plus the negative 5 over x minus 1 by changing it to a subtraction problem. So 2 over x minus positive 5 over x minus 1. And so it turns out I've already submitted this problem. And when we did check it, wahoo! It said it was correct when we substituted in our value like so. So I hope this problem on partial fraction decomposition when you have distinct linear factors was helpful.